Welcome to Cosworth, a company with a tremendous reputation in road and racing for building engines, including having the most successful Formula One engine of all time. They've been chosen to design, develop and build the engine for T.50. Now, an engine is the heart of any supercar, and that is certainly the case with T.50, although T.50 is going to be a little faster than the others. Now, Gordon and the team at Gordon Murray Automotive have always had a very clear vision for T.50. But for those of you watching, it's really been a car of numbers up until this point. 986 kilos, 650 horsepower, 12,100 RPM. But now we're going to see the soul. The emotion's going to start coming out as we hear its voice for the first time. Let's go find out what Cosworth are up to. Engine build shop at Cosworth. Jack, engine builder extraordinaire. Let's start at the bottom of the Cosworth V12. It looks like a racing engine.
Yeah, pretty much is a racing engine, to be honest. Everything's finished to a good surface finish, and yeah, it's a thing of beauty, really.
It is stunning. It's the things I notice from my very untrained eye is the individual compartments for each part of the crank.
Yeah, that's not really much you see on production cars, especially as well with a dry sump. You only really see that on race engines and track cars, to be honest.
Is that just a performance thing?
Yeah, strictly just a performance thing. And then you don't have so much weight at the bottom, you know, it's not moving around. Whereas you think of a wet sump, you know, you go around a corner, all those G-forces will push all the oil over to one side. So it's just, you know, better to have it. And you can lower the centre of gravity as well by having a dry sump.
Yeah. And plus this is not churning through the oil.
Yeah, exactly, yeah.
As far as the crank, because it's spinning so quickly, 12,100, what are the tolerances on balancing this thing?
Incredibly small. So obviously, because it spins so fast, you're going to have to balance it really precisely. So these all get balanced over the road where we make our own cranks. And yeah, that's where they get finished to this high quality as well.
It's lovely. So let's move on further up the engine. The block. So inside, what are those bits inside?
They're squirt jets, so they'll cool spray oil on the underside of the piston, and then it will cool it.
It really stands out. The other thing that stands out to me is externally, so it's all cut away to save weight, but yeah. Is it just me, or does it look like an old sort of 60s F1 engine?
Yeah, very reminiscent of those engines.
Yep, outside.
Yeah, not necessarily inside.
Let's have a look at the inside. So, I mean, well, let's start with the piston. This is your life. I mean, I'm normally the guy that breaks the engines, but you've seen a lot of engines in your time. Is that normal, the piston that size?
Not for a road car, no. I wouldn't say for a road car in particular, but for high performance engines and race engines, it is.
But it's tiny. To give it some perspective, here's one we made earlier from a more normal car, and the weight difference is bigger than the visual difference.
Yeah.
I mean, it's really incredible. What's the green part?
So that's a super slippery coating. So when it comes in contact with oil, it just helps it to go up and down the cylinder. So you're trying to gain every single performance from the running of the engine, and yeah, it just helps it run better, really.
And what's the piston made out of?
It's made out of a material called MMC, so it's metal matrix composite.
And is that super secret, what that composite is?
Well, it's never been used in a car on the road, so this will be the first application of it being in a road car ever, really, in the world.
The more I see of this car, the more the individual details stand out. I mean, I don't even want to touch. What is it a piston ring?
Yeah, well, it's an oil control ring, so it sits just below the piston rings, so that helps retain the oil and helps keep the engine lubricated.
Minuscule.
Yeah.
And how do they know how little you can get away with? Because most, I mean, again, there's a normal piston ring. It's multiples the size.
Well, mostly, you know, Cosworth built a lot of engines, so it's, you know, quite handy to have that experience. And then they also go by a lot of it's done in computers now, so you can simulate what would happen in real life, basically.
Right. So. That's tremendous. Let's move further up the engine. So, We're nearly at the top of the engine, the valve train. It's like it's in miniature from what I'm used to seeing.
Yeah.
And
everything's so compact.
What is this part?
So that is what is between the cam lobe and then the tip of the valve.
Right.
So that effectively, the cam will come round, push this down, and then onto the valve, and the valve will open.
So at 12,100 RPM, this little fella's got quite a bit of work to do.
Yeah, moving very fast.
Talking about work, valve spring. Back in my day, when an engine was revving, a racing engine was revving at 12.1 and above, it was always about valve springs and the valve springs breaking.
Yeah.
How is it possible that a road car can rev that hard?
Just the materials have come on so far, and the actual knowledge of everything has come on quite a lot. And you can see there's a spring inside a spring there, so it almost, you're making the most use out of all the space really.
So I guess the next step would be sort of air valves.
Yeah, that would definitely be the next step up.
And all the stuff that, all the problems that brings. Finally, bracing myself to lift it there. There's the top of the engine. What is that made of?
That's made out of magnesium.
I think Gordon will be happy when he feels the weight of this. Even Gordon. It's ridiculous. So can we look at, we've seen all the components together, can we look at one that's sort of somewhat put together?
Yeah, we've got this one that's just come off the dyno, was having a bit of an inspection.
The first thing I'm looking for, where are the belts?
There isn't any belts, it's completely gear driven, so it comes off of a crank, a gear here, and then it just gets transferred up through into the cams.
What are the advantages to that?
It's more instant, it's pretty much almost like a direct connection straight to your cams, and everything can react a lot quicker, it can take higher RPMs, it's just a lot better really.
More expensive to do?
Absolutely, yeah, a lot more expensive.
I'm seeing the oil here. What kind of special oil do we have to run?
So it's pretty standard oil, to be honest. You can buy it off the shelf. It's Shell, it's 0W40, and you could buy it for any car really if it's designed to go in your car really.
Must be good. Jack, thank you so much for your time. Well, that's it here from the build shop at Cosworth. As you can see, the engine is full of these tiny, intricate, beautiful details, and it is going to be a phenomenal power plant for T.50.